For this presentation, I will be explaining what we will be working with. Right here we have our material, SM55, and everything else we'll be working with is water. We have a tank identical to the one we contain our material, filled with 2 gallons of water. Here we have a base made of glass, filled with water. And here we have 3 bowls, one made of glass, one made of aluminum, and one made of steel. You'll notice that there's black dots on the bowls. This is just marker Sharpie, and we're doing that because the color black absorbs the most heat. We also have crayons, so when we touch the hot spots, we don't burn our own fingers. And we're using MAP gas, which burns at around 3,700 degrees Fahrenheit. We also have a timer. And last but not least, we have ice. All the water and our material, it's at room temperature, which is around 60 degrees. The water is at 57 degrees. All of them. And our material is in between 59 and 60 degrees. The ice, it's at 32.5 degrees. So we're going to start the test by placing the ice into the 3 bowls containing the water. I'm going to start a timer. And now I will place the ice. As you can notice, the temperature drops right away. Our material is still at room temperature. Now for this demonstration, we're also going to try to heat up the water inside this glass container, which is at room temperature. Since it might be hot, I'm going to be touching it with a crayon instead of my own finger, just for my own protection. I'm going to hit it for 15 seconds. 11, 8. That blew up. I guess it was no good. I guess I can't use this anymore. Let's get this mess out of the way. As we can see, glass is not a very good medium to transfer heat. Now we have our 3 bowls. Again, one made of glass, one made of aluminum, and one made of steel. They're already cooling down. This is the actual container, not the water on the inside. 42 degrees, 50 degrees, and 38 degrees on the steel. $47 in the glass, 50 on the aluminum, and 38 degrees on the steel. And our material is still at room temperature. We're also gonna try heating up this once as well. Again, I'm going to try to use a crayon instead of my own finger for my own protection. Each one of them, I'm going to be heating up for 15 seconds. As you can see, this is melting the crayon right away. I really wouldn't want to touch that. If this is too hot and it could injure me, this is not our material. That was aluminum. Now we're going to do steel. As you notice, we don't have a black dot placed on this one because the whole container is already black. Thus, we don't need a black dot. 15 seconds. Again, I'm going to use a crayon for my own safety. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Again, it's melting the crayon right away, so I'm pretty sure that's not healthy for me. This was steel. Now we're gonna try glass one more time. This time with the ice, maybe it will be able to survive the heat. I will heat it up for 15 seconds. 1, 2, 3, 4, 5, 6, 7, 8. Again, it broke, and if you'll notice, it did it in 8 seconds, just like it did when it was just water without ice at room temperature. Thus showing that glass is not a good medium to show heat transfer. Our material is still at room temperature. Now we're going to heat up our material. We're going to heat it up for 30 seconds. As you'll notice, 6.5 minutes have gone by. Our material is still at room temperature, and the water with ice is at 31 degrees. Thus showing that there's no ice in this container. I'm going to heat it up for 30 seconds, and then I'll use my bare finger to touch it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Crayon, nothing's happening. Do it another 30. I'll try it again. Another 30 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Nothing.